Data types and variables. Part 1. Here are the contents. What is a variable? Compilers roll with variables. Properties of variables. Identifiers and variables. Ways of storing variables. Variable types and type conversion. First, we will look at what is a variable. In computer programming, a variable is a symbolic name given to a data storage location containing some known or unknown quantity or information. A variable name in computer source code is an identifier that can be bound to a value during runtime, and the value may change during the course of program execution. Variables in programming may not directly correspond to the concept of variables in mathematics. Variables in computer programming are frequently given long names to make them relatively descriptive of their use, whereas variables in mathematics often have terse, one or two character names for brevity in transcription and manipulation. Compilers have to replace variables' symbolic names with the actual locations of the data. A variable's name, type, and location often remain fixed. The data stored in the location may be changed during program execution. Now we will look at what are the properties of a variable. First one is lifetime. Containers for global variables are created once. Containers for local variables are created every time a procedure is invoked. The other one is identifier and value. Identifier of a global variables is an input to the global command which declares it. Identifier for local variables. Input for local variables get their initial values from actual arguments provided on procedure invocations. Identifiers and variables. An identifier referencing a variable can be used to access the variable in order to read out the value or modify the attribute of the variable. If a variable is only referenced by a single identifier, that can simply be called the name of the variable. Variables are stored in memory, but in different ways depending on how they are used. They are globally, on the heap and on the stack. When storing globally, all the part of the program can access and change the value. Access is done via pointer variables when stored on the heap. When storing on the stack, a block of memory that is used to store parameters into functions and variables that exist local functions. variable types. Variables are defined according to the type of data. In Fortran, these 6 types of variables are used: real, double precision, integer, logical, character and complex. In Algol 60, only 3 types of variables are used: integer, real and boolean. Type conversion is concerned with changing an entity of one data type into another. One is implicit type conversion and the another one is explicit type conversion. Implicit type conversion is also called as automatic type conversion or automatic widening. In this type, all operands have to be of the same type and no information is lost after the conversion. It is called legal when the assignment conversion is widening, and it is illegal when the assignment conversion is narrowing. Let's consider an example for implicit type conversion for legal. Declare an integer type variable called I and assign a value as 5. Then declare double type variable called A and assign value as 10.5. Then declare another double type variable called C and assign a value as A plus I. Here I is widened to a double. It is legal. Let's consider an example for implicit type conversion for illegal. Declare an integer type variable called I and assign a value as 5. Then declare double type variable called A and assign value as 10.5. Then declare another integer type variable called C and assign a value as A plus I. Here A is narrowing to an integer. It is illegal. Explicit type conversion is also called as explicit narrowing conversion or typecasting. The conversion is defined within the program. Information will be lost in this type of conversion, and the conversion is done by the compiler. You can see when converting from a double to an integer, the fraction parts are ignored. Let's consider an example for explicit type conversion. Declare a double type variable called B and assign a value as 2.345. Then declare integer type variable called I and assign value of D as above. Here I value is equal to 3. Fraction parts are ignored by the compiler. Here some information will be lost. This is called explicit type conversion.
Data types and variables. Part 2. Here are the contents. Scope and extent of a variable. Type checking methods. An overview of typing. What is a data type? Early data types. Present data types. Advantage of data types and conclusion. Scope of a variable describes where in a programming text the variable may be used, while The extent describes when in program's execution a variable has a value. The scope of a variable is actually property of the name of the variable, and the extent is a property of the variable itself. Most languages define a specific scope for each variable. This may differ within the given program. Extent, on the other hand, is runtime aspect of a variable. Each binding of variable to a value can have its own extents at runtime. The extent of the binding is a portion of the program's execution time during which the variable continues to refer to the same value or memory location. Running program may enter a leap given extent many times, as in the case of a closure. In portions of code, a variable in scope may never have been given value, or its value may have been destroyed. Such variables are described as out of extent or unbound. In many languages, it is an error to try to use the value of the variable when it is out of extent. In other languages, doing so many is unpredictable. Type checking methods. First one is static typing. Static typing means that type checking is performed during compile time as opposed to runtime. Static typing is a limited form of program modification. It allows many type errors to be caught early in the development cycle. Static type checkers evaluate only the type information that can be determined at compile time. Program execution may also be faster or taking reduced memory by omitting runtime checks and enable other optimization. Some of the most commonly statically type check languages include C, C++, C#, Fortran, Java, and etc. The other method is dynamic typing. A programming language is said to be dynamically typed, and majority of its type checking is performed at runtime as opposed to at compile time. In dynamic typing, values have types, but variables do not. That is, variable can refer to a value of any type. Compared to static typing, the dynamic typing can be more flexible. Dynamic typing may result in runtime type errors, which at runtime a value may have an unexpected type, as if place whether wrong type of data passed into a place it should not have. This may make it difficult. Development in dynamically typed languages is often supported by programming practices such as unit testing. This method can detect a much wider range of errors than static type checking. Dynamic type languages include JavaScript, Perl, PHP, Prolog, and etc. Let's take an overview of both statically and dynamically typed languages. First one is static typing. The following diagram represents is description of one of the ways these terms are most commonly used. In statically typed language, every variable name is bound both to a type and to an object. The binding to an object is optional. If name is not bound to an object, the name is to be null. Once a variable name has been bound to a type or declared, it can be bound only to objects of that type. It cannot ever be bound to an object of a different type. An attempt to bind the name to object of the wrong type will raise a type exception. In a dynamically typed language, every variable name is bound to an object unless it is null. Names are bound to objects at execution time by means of assignment statement, and it is possible to bind a name to objects of different type during the execution of the program. A data type is a type of data. Of course, that is rather circular definition and also not very helpful. Therefore, a better definition of a data type is a data storage format that can contain a specific type or range of values. Then we discuss what are the various data types. First of all, we discuss early data types. Fortran. Fortran was first generation language. There are 6 basic data types. These are real, double, precision, integer, logical, character, and complex. ALGOL 60. ALGOL was second generation language. There are 3 data types in ALGOL 60. These are integer, real, and boolean. Also, no implicit declaration and no complex number types. Pascal. Pascal was third generation language. Pascal supports 4 standard data types, which are integer, real, boolean, and char. Ada. Ada was 4th generation language. It has 3 data types: character, string, and integer. Then we discuss what are the present data types. C data types. In the C programming language, data types refers to an extensive system for declaring variables of different types. It is divided into main 2 types, which are primary and secondary. Example for primary data types are characters, integer, float, double, and void. Example for secondary data types are array, pointer, structure, and union. C++ data types. C++ offers the programmer a rich assortment of built-in as well as user-defined data types. Examples for the C++ data types are Boolean, character, integer, floating point, double floating point, valueless, and void character. Java data types. There are two data types available in Java: primitive data types and object data types. Java data types are Boolean, byte, short, integer, long, float, double, and char. C# data types. C# is strongly typed language, therefore every variable and object must have a declared type. C# data types are integer, string, boolean, byte, double, and float. Advantages of data types: allows you to efficiently store data without waste, allows you to write your application code without re-implementing standard data types, allows code and subroutine parameters to be more expressive, and better execution speed. This video helps to understand about data types and variables from the beginning. Someone who don't have any idea about these sections can go through this video and easily improve their knowledge about data types and variables. Thank you.